Very good morning to all. I welcome you to GATE lecture video. Myself Malathi, Assistant Professor, Department of Mathematics, A.C. Engineering College. Today we are going to discuss about the topic rank of a matrix. So the content of the matrix is elementary transformation of a matrix, method to reduce a row echelon form, problems based on row echelon form, rank of a matrix, properties and simple problems. So first we discuss about the rank of the matrix definition. The rank of a matrix is the maximum number of linearly independent within the matrix. It is represent the dimension of the vector space. Okay. The next one is elementary transformation of a matrix. The matrix can be transformed into another matrix by certain operations called elementary transformations. The elementary row and column operation is, the first one is the interchanging of any two rows of the matrix, replacing a row of the matrix by a non-zero scalar multiple of the non-zero scalar. Replacing a row of the matrix by a sum of the row with a non-zero scalar multiple of another row of the matrix. So this is the basic definition about this topic. The next definition is equivalent matrix. If you consider two matrices A and B is said to be equivalent to one another if one can be obtained from the other by the applications of elementary transformations. We write simply A union B to mean that the matrix A is equivalent to the matrix B. So the next one is how to reduce the matrix in a row echelon form. So the first step is inspect the first row. If the row is a zero row, then row is interchanged with another row. So below the first row. If A11 is not equal to 0, proceed to step 2. Otherwise, interchange the first row R1 with any other row below the first row which has a non-zero element in the first column. If no row below the first row has non-zero entry in the first column, then consider as A12. If A12 is not equal to 0, proceeds step 2. Otherwise, interchange the first row with any other row below the first row which a non-zero element in the second column. Proceeding this way, you go to the next step 2. Use the first row and elementary row operations to transform all elements and the pivot to become zeros. Next step is consider the next row as first row and perform step 1 and step 2 with the below this row only. Repeat this step, we can get the row echelon form. The example, how to reduce the matrix into row echelon form. Okay. So the first row is 3 minus 1 2, the second row is minus 6 2 4, third row minus 3 1 2. Okay. So see the first element in the first row, it is a non-zero element, so we can proceed the next step. So this first row, the corresponding pivot element tends to 0. So using the operations R2 implies R2 plus 2R1, R3 implies R3 plus R1, we can get this 2 pivot element corresponding the first row, it tends to 0. The next term is consider the second row, the corresponding pivot element, this element is also tends to 0. So this is the row echelon form. If it is possible, this 8 can be reduced into 1, otherwise no need, so you can proceed that. So this is the row echelon form. So the rank of the matrix is, the third row vanishes, so the rank of the matrix is 2. Similarly, the second example, reduce the matrix to row echelon form. See this matrix, so the first element is 0 element. So we convert into non-zero element using the elementary transformation. The second row interchanging into first row interchanging into second row, the first step. So see this, the first element is the non-zero element. So using the next step is the corresponding pivot element tends to 0. So using the operation R3 equal to R3 plus 4R1, this term tends to 0. The next one is you reduce this term tends to 0 using the second row. So the operation is R3 equal to R3 minus 2 by 3 R2. So 3 0, 22 by 3 16. So see this. See this. So this is the row equivalent form. So this is the step to reduce the matrix to row equivalent form. The next exam definition is the rank of a matrix. The rank of a matrix is defined as the order of a highest order, non-vanishing minor of the matrix A. It is denoted by the symbol row of A. The rank of a matrix is zero matrix is defined to be 0. The rank of a zero matrix is defined to be 0. So this is the rank of a matrix definition. The next topic is basis equivalent form. So reduce the how to find out the rank of a matrix means it is one of the method to find the rank, that is the equivalent form, row equivalent form. So the basic step is find the rank of a matrix. The number of non-zero rows of a matrix reduced in equivalent form is called the rank of the matrix. A matrix is said to be equivalent form if there are any zero rows, then they should be placed below the non-zero rows. The number of zero in front of any row increases according to the row number. The non-zero rows of an equivalent matrix are that linearly independent row vectors. The rank of a matrix A is denoted by R of A or row of A. So this is the equivalent form by the rank of matrix. So this is the basic properties of rank of matrix. The first property is A be any non-zero matrix of any order, and if denoted by row of A less than order of A, then A is singular matrix. Only the rank of a null matrix is 0. The next one is rank of a identity matrix is 1, the order is also 1. The rank of a M cross N matrix is a minimum of M and N. Next, if A dash and A star are the A dash is the transpose matrix and A star is the transvect matrix, then row of A dash equal to row of A and row of A star equal to row of A. So the next properties, two row equivalent matrices, the rank of the matrix, rank of A plus B is denoted by less than or equal to rank of A plus rank of B. Rank of row of A minus B is denoted by greater than or equal to row of A minus row of B. If A and B are two matrix conformable for matrix multiplication as rank of AB, that is row of AB less than or equal to minimum of row of A comma row of B. If the order of a square matrix A is M, then M minus row A is the nullity of a matrix A. So these are all the basic properties for rank of the matrix. Now we are going to discuss the few sums for rank of a matrix. See the first problem. The rank of a matrix is this. Find the rank of this matrix. That is the question. So using the row equivalent form. So see the first element, it is a non-zero element. So this is a non-zero element. So the corresponding pivot element is 2 and 4. So using the conditions R2 implies R2 minus 2R1. Next R3 implies R3 minus 4R1. So this can be, the matrix can be reduced into 1, 1, 0, minus 2. So the 2 minus 2 is 0, and then 0 minus 2 is minus 2. 2 minus 0, 2. 2 plus 4 is 6. Next, using this operations, 4 minus 4 is 0. 1 minus 4 is minus 3. And then 3. Next, similarly, 1 plus 8, 9. So this is the next step. So see the second and third row. The second row is divisible by 2. The third row is divisible by 3. So R2 implies R2 divided by 2. R3 implies R3 divided by 3. So this can be 1, 1, 0, minus 2, 0, minus 2, 2, 6, 0, minus 3, 3, 9. Sorry. So 1, 1, 0, minus 2. So this row divided by 2, minus 1, 1, 3. The next one is divided by 3, minus 1, 1, 3. So next, using the operations, R3 implies R3 minus R2. So 1, 1, 0, minus 2, 0, minus 1, 1, 3. Next one, 0 plus 0 minus 0, 0, minus 1 plus 1, 0, 1 minus 1, 0, 3 minus 3 is 0. See that this is only two non-zero matrix. The third row is vanishes. So the rank of the matrix is 2. So the next example, the rank of a matrix A equal to, so this is the matrix. See that in first element it is a non-zero element. The first element is non-zero element. So this is a non-zero element. So proceeding in that way, the corresponding pivot element tends to 0. So this can be written as, so first row there is no changes in the first row. In second row, the second pivot element is already 0. No need to simplify that. The third row is the pivot element is 0. See the fourth one, this is the minus 1. So this can be reduced into 0. So the R4 implies R4 plus R1. So minus 1 plus 1, 0. So 0 minus 1, minus 1. 0, 0, 0. 0 plus 0, 0. 1 plus 0, 1. So the last element is also 0. So 1 minus 1. So next see the second column. So this 2 element tends to 0 based on R2, but in second row A2 value is not, it is 0 element. So rearrange the row, R2 replace into R3. So this can be written as 1, minus 1, 0, 0, 0. So 0, 1, minus 1, 0, 0. The next one is 0, 0, 1, minus 1, 0. Okay. The next one is 0, minus 1, 0, 0, 1. Finally, the last row is 0, 1, minus 1. Now, this element tends to 0 based on R2 using the operation R4 implies R4 plus R2. So this can be written as 1 minus 1 0 0 0 0 1 minus 1 0 0. The third pivot element is already 0, no need to simplify that. This one tends to 0 0 0 0 minus 1 0 0. So the next one is 0 0 0 1 minus 1. So similarly, using this term tends to 0, adding this two element, we can get that the rank of the matrix is 4. So the third question, see the question, the rank of a matrix A equal to 1 1 A B C A square B square C square. Here the condition is given A equal to B, A equal to B, B not equal to C. So this is the condition of this matrix. So you can find out the rank of this matrix using the row echelon form. See that. So what is that? See the first element, it is a non-zero element. So proceeding that. So R2 implies R2 minus A R1. R3 implies R3 minus A square R1. So 1 1 1 0 B minus A C minus A square 0. So B square minus A square C square minus A square. So the condition is A and B are equal. So this can be written as 1 1 1 0 0 C minus A 0 0 C square minus A square. So this is the final echelon form. So no row vanishes. So the rank of the matrix is 3. See that if A and B are 3 cross 3 matrix, real matrix, such that the rank of AB equal to 1. So the question is rank of BA cannot be. So rank of AB is equal to R. Rank of AB is equal to R. Rank of BA cannot exceed R. Cannot exceed R. So the rank of AB is 1. So this cannot be exceed 1. So the rank of the matrix is 2. Rank of BA cannot be 2. Fifth sum, see that let P equal to some 3 cross 3 matrix is given, Q equal to 3 cross 3 matrix is given. You find out that rank of P plus Q. So first you add this two matrix. First you add this two matrix P plus Q is equal to the corresponding element 1 minus 1 0, 1 minus 2 minus 1, minus 1 minus 1 minus 2, next to 2 plus 6 8, 9, அடுத்து 6 plus 4 10, 3 plus 5 8, 10 minus 2 8, next 3 plus 5 8. Now using the row echelon form, so see the first element, it is a 0 element. So interchanging rows, so R1 interchange into R2. So this can be written as 8, 9, 10, 0, minus 1, minus 2, 8, 8, 8. So using the row echelon form, R3 implies R3 minus R1. So this can be 8, 9, 10, 0 minus 1 minus 2, 8 minus 8 is 0, 8 minus 9 is minus 1, 8 minus 10 is minus 2. Finally, R3 implies R3 minus R2. This can be 8, 9, 10. Next, 0 minus 1 minus 2, these are all 0. So, one row vanishes. So, the rank of the matrix is 2. The next question is, let the rank of matrices A is 3. The size of the matrix is 3 cross 5. See that? The rank of the matrix A is 3. The size is 3 cross 5. The second matrix, rank of B is 5. The size is 5 cross 7. So, the question is, find rank of AB. Find rank of AB. So, using the properties, rank of AB is less than or equal to minimum of rank of A, comma, rank of B. So, less than or equal to minimum of rank of A is 3, 5. So, the minimum value is 3. Again, using the one more property, rank of AB is greater than or equal to rank of A plus rank of B minus column value of first matrix. So, rank of AB greater than or equal to, the rank of A is 3, rank of B is 5, the first matrix is A, the column value is 5. So, 5, 5, 3. So, see that rank of AB less than or equal to 3, rank of AB greater than or equal to 3. Now, we conclude that rank of AB equal to 3. So, the answer is 3. The next question. Let A be a 4 cross 3 real matrix with rank 2. Which one of the following statement is true? So, generally rank of A is equal to rank of A transpose A. So, the answer is 2. So, rank of A, the answer is B answer, rank of A transpose A is equal to 2. The next question, 8th question. See that, let A be a M cross N matrix and B be a N cross M matrix with M less than N. Then, see that, so A is a matrix, the size is M cross N. B is the matrix size is N cross M. The condition is M less than N. For example, suppose you consider M equal to 2 and N equal to 3. So, A equal to, the matrix is 1 0 1 0 1 0. B is 1 0 0 0 0 1. So, you find out BA. The determinant of BA is not equal to 0. Sorry, the determinant of BA equal to 0. So, this is a singular matrix. So, BA is always singular. Otherwise, rank of A, the condition is the order. Rank of A less than order of A. Rank of B is also less than order of B. So, we conclude that rank of A, BA less than A. So, BA is always singular. That is the correct answer. The next question, already we see in the properties, rank of AB is a N cross N real matrix. Which statement is correct? So the first statement is correct statement. So already we discussed in the properties, rank of AB less than or equal to rank of A plus rank of B. The last questions. So this method is already referred to the previous problem. Let P and Q be two real matrices of size 4 cross X, 4 into X and 5 into 4. So see that. So P is the one of the matrix. The size is 4 cross S, 6. Q is another matrix. The size is 5 cross 4. So the given condition is rank of Q is given, the rank of Q is 4, and also rank of QP is 2. So you find out rank of P is what. So using the properties, you know that rank of QP, it can be written as rank of Q plus rank of P. So rank of QP is 4, less than or equal to rank of QP is 2. Rank of Q is 4. You don't know the rank of P, so you consider as X. That is minimum of rank of Q comma rank of P. So minimum of 4 comma X, you know that 2 less than or equal to 4. So it may be minimum value, so you consider as 2 less than or equal to X. And then one more property, you know that rank of QP is greater than or equal to rank of Q. Rank of Q is 4. Rank of P is X minus the column value of the first one. The value is 4. This 4 cancel. Rank of QP is what? 2. 2 greater than or equal to X. Here we see that 2 less than or equal to X, 2 greater than or equal to X. So we conclude that X equal to 2. That means rank of P is 2. So these are all the example. Thank you. We will continue in the next session, GATE video. Thank you.